from the positive side. And we've talked a little bit about left and right hand limits, so hopefully that will help you here. Okay. Oh, this is the function, right, that we're graphing and so on. Okay. So now I have the limit here, and I've got 1 over x. So 1 divided by x. Right. So it's the same function. Just box it each time so that you can see that this is the same function we're talking about. Okay, but now what do we do? So in this circumstance, what am I going to do? So what I want to do is I check what happens as I sub in smaller and smaller positive x values. So there they were larger and larger. Now they're smaller and smaller, right? Because this picture, we should always keep this in mind. If I'm approaching, right, so what's going on is if I'm approaching when I have 0 plus there, it means, oops, I keep on swapping plus and minus today. This seems to be a problem for me. But we're going to approach from the other side. We approach from this side. Okay, so we have positive values that are very close to this. Okay, so we're going to check what happens as we sub in. So what do we do here? We check what happens. What happens as we sub in, so we want to get smaller and smaller because we want to approach 0. So smaller and smaller, and then we're coming from that side, so they should be positive. So smaller and smaller, positive x values. Okay? So they should be positive. They should be getting smaller and smaller because we're approaching 0 like that. So we can kind of go ahead and do this. So we have 1 over, so like 1/10. So what are some values that approach 0? This might be kind of tricky to think about, but I'm actually going to kind of reuse the fact that I know that these kind of approach 0. We've already talked about that. So I'm going to go 1 over 1/10, right, which is going to equal 10. And then 1 over 1/100th, right? If something is on the bottom, we flip it. So we get 100. And we've already know that these are getting smaller and smaller, remember, on the bottom, because we've cut, it's like cutting it into more and more pieces, right? This gives me 1,000, and so on. So you can kind of see what I'm actually happening is I'm getting bigger and bigger positive as my output. I'm inputting smaller and smaller positive as something that goes on the bottom as my input, and then I'm getting as my output something that's larger and larger positive. Okay? So there's kind of a principle here, and I've heard people describe it like this before, and I kind of like this, so I'm going to use this for you, give this to you also. Okay, which is what happens if I get very, very small positive on the bottom, like I have here, that's actually going to approach positive infinity. Okay, so let's kind of, I'm just going to kind of write out what I mean by this is that I'm getting, I haven't been using red, really, let's use that a little bit more. So very, very small positive. Okay, so if I have very, very small positive, that approaches positive infinity. So the picture that I'm going to have here, I cheated because I sometimes drop pens, so I brought an extra set here so I don't have to keep on reaching down for them. Okay, and so we have here, we have, except that for some reason or another, the orange ones, when they're brand new, they're not very easy to see. You can see it's kind of light. I'm not exactly sure why that is. Okay, so there's my axis there. This is my x-axis, and then I've got my y-axis here. And my function, right, so I've got 1 over x, and we've already kind of seen, so over here, this is what my 1 over x looks like. So as I'm approaching here, you can actually see this happening. So this is what I mean when I have x, right, goes to, it's the right-hand limit there of 0. then you can actually see what's going on here is that the 1 over x gets really, gets infinitely big. So 1 over x gets infinitely big. Like our output here is getting infinitely big as our x is closing in on 0 from the right-hand side. Okay? This is a little bit small. Okay, so we can see here that actually what's kind of happening here, right, is 1 over x, right, is going towards infinity. Sometimes we write positive infinity, sometimes we just write infinity. We mean infinity when we do that. Okay, so what we get then in this circumstance is that the limit as x approaches 0 from the right-hand side of 1 over x is going to equal infinity, or you can put a plus in front just to extra emphasize that if you want, but we know that without a plus 2, it is positive infinity. Okay? And then the last example I want to go through, so this is example 4. Okay, so here what I want to do is I want to take the left-hand limit. So I have x is going to 0, and we're doing the left-hand limit here. Okay, and this is going to equal, so we're going to get that this is the limit as x approaches from this side of 1 over x. 1 over x. And I'm really unhappy with this one, so I'm picking up the other. Okay, so 1 over x. I don't know why that one. These are all brand new, but for some reason that one just was. It just came out of the machine, just not as strong. Okay. So we're taking this limit here. So what do we do now? So this tells me that I need to, right, well, first off, always good to draw the picture. So we're approaching 0. I'm going to use red this time to say that we're, right, this is the 0 minus side, right, like over here. Right, if I was doing it from the right, that would be the 0 plus side, but I'm doing it from the left, so that's the 0 minus side. Okay, meaning I'm looking at negative values, right? So this is going to tell me that I need to check what happens as I sub in smaller and smaller negative x values. Okay, so I want to check what happens. So check what happens as I sub in. So as I sub in, so again, it's still smaller and smaller, but now it's negative. So smaller and smaller, negative x values. So negative x values. Okay, so let's go ahead and do that. So it's the same kind of deal. I'm just putting minuses there. So I have 1 over, so I have 1 over, so we have a minus here, 1/10. Okay, and then, so that's going to equal minus 10. And then I have to go 1 over, and then I have 1 divided by minus 100. So I get out minus 100. And you can kind of figure out the pattern here pretty quickly. So I'm going to go 1 over minus, I guess that minus more typically would go right there. Okay, so minus 1 over 1,000, which is going to equal minus 1,000. Okay, and then what do we end up getting? So there's kind of an analog to this here. So what I have going on is I have 1 over, so now it's going to be very, very small, but negative. So it's, we can write it like that. And again, just kind of emphasize this is very, very small negative. And when we have 1 over very, very small negative, then we end up getting that this goes to minus infinity. right? Because we have this picture, and I didn't draw the picture there, but you can actually see this picture here. So maybe we'll share this picture. These are right next to each other anyway. That what I'm doing here is I'm approaching, right? So if I approach this instead, so at first I was going as x goes to minus infinity, but now I'm going as x goes to 0 plus. I'm not going to share the picture. I feel like it's way too crowded, so let's not do that. Let's just draw new over here. So we have like this, and then we have like this, and this is my x-axis. Okay, you can see that. And now our x is approaching 0 from the left-hand side, so we put the 0 minus there, and our 1 over x values are going to get, they're going to get infinitely big negative, right? So 1 over x gets infinitely big, but negative. Okay, so putting all that together, I'm going to get that the limit as x approaches 0 from the left-hand side, okay, of 1 over x is going to equal minus infinity. Okay, let's box this, and then we can kind of recap everything we did, because a lot went on here. Okay, so we're looking at when we have something in the denominator. It doesn't need to be x, but with x, it's the easiest to see kind of the principles going on, okay? And the principles going on are, well, we know if we put bigger and bigger things in the bottom, which is the same thing as x going to infinity, if we put bigger and bigger things in the bottom, then just like slicing up a pie into more and more pieces, the pieces get smaller and smaller. So what we're getting out is approaching 0, and so our limit is 0. If we get bigger and bigger things in the bottom, but they're negative, it actually doesn't impact it because we're just getting smaller and smaller negative things, but they're still approaching 0. Okay, so that's what's going on in those two circumstances. You're going to see those circumstances showing up with other functions, which is why I kind of wanted to go through that. So what happens? Okay, so now I'm approaching 0 from the right-hand side, so that's where we have this kind of plus sign there. And in that circumstance, we're putting in smaller and smaller positive x values. Well, what happens when you put in smaller and smaller values on the bottom? It's kind of like having 1 over something on the bottom, you know, and so you flip it over and it gets really big, right? You flip over small, you get big. You flip over big, you get small. You can kind of think of it a little bit like that. And so what's happening is on the bottom, you have very, very small positive, and this kind of limit goes to plus infinity. Okay, and you can kind of see that in the picture. If we add a negative to that, instead, right, so as we approach from the left-hand side here, we're looking at negative values, but they're negative very, very small, and so when you flip them, you get negative really, really big, which is going to lead you to minus infinity. And we're kind of going to abbreviate that situation sometimes as like VVSN, or very, very small negative on the bottom. But when you have 1 over very, very small negative, that is actually going to approach minus infinity. The last thing I kind of want to emphasize is that while we do put a minus in front of the minus infinity, sometimes we put a plus in front of the plus infinity, and sometimes we leave it out. Okay, so I hope that made some sense, and I'll see you in the next lecture.